No agua. So welcome back with today's question. So today's question is implementing queue using stacks. Yeah. So I assume that you know what a queue is, what a stack is. It is just what it says, like verbally. What is a queue? People stand in a queue like this. Uh, this is the first person in the queue, second person in the queue, and whatever service they're waiting for. The first person to go into the queue will be the first person served. That is, the first person going into the queue will be the first person coming out of the queue. And stack is what is exactly what it says. Stack, like let's say take a stack of books. The last book that you put will be the first book to take out, and the first book that you put will be the last one to take out. So that is basically what a queue is and what a stack is. So, where's the reason? Yeah. So today's question is like relatively easy. We have to implement queues using stacks, and the question says exactly 2 stacks, and then we have to implement 4 functions. Push, that is pushing into a queue. Pop is popping out of a queue. Peek is just looking into the queue, and then boolean empty is just checking if stack is empty or not, just like your ex's heart. Okay, so so we have to implement queue using 2 stacks. So the first thing that comes into our mind is, so queue is like simply like this. It's a queue. We have 2 stacks. Sorry, we have 2 stacks, and then we have to implement the functionality of a queue. So I'll drop both. Okay, this is what we have, and this is what we need. So let's say let's take an example. We are putting one element into the queue. So we're pushing one element into the queue. Let me call it 1. So in stack also we have to push one element 1, and then I push one more element into the queue 2. So I have to put one more element 2, and I'll put one more element 3. So I have to push one more element into the stack 3. So now the question is, now if I pop from this queue, the first element to go has to be the 1. Yeah, 1. She's for the streets. I'm just kidding. So 1 is there outside. So it's popped. Now we have to pop from the stack 1. But how do we do it? Because 1 is deep down in the stack. So we can't remove 1 unless we remove 3 and 2. So we have no other option than to pop these 2 elements here, or pop everything here and put them into the different stack. So it will be like 3, 2, 1. So these 3 elements are like popped here and pushed into this stack. Now we can send out 1. Yeah, so that we can do. Now we have to keep doing this again. So now let's say I put the next element. I've put 4. But how do I put 4 inside this? 4 has to be like after 2, 3. The order is gone. You can't do 4, 2, 3. So I have to like again bring them back here. So 2, 3. So now they're in order, and you put 4 here. Now you have to keep repeating that. So the thing is, whenever you have to think, like whenever you have to push or pop, depending on what you want to optimize, like let's say, then you have to do like n operations. You have to either pop them here or pull them there, all these things. So every time you pop or every time you pull, you have to like, if every time you have to pop, let's imagine you have to take all these elements, you pour into these elements, and then pop from here, and then you have to bring them back here for your ordering, so that your order is not gone. So pop takes of n time complexity. Even the push will take only of 1, we're just pushing in, and peeking is just like pop. So that will also take of n, peep and pop, and then push will take off 1. And what else was empty is just checking both the stacks are empty or not, so that will be like off 1. That is fine, but this is too slow. I mean, it's not slow, but off n is fine. But for this operation, we don't need of 1, because they're also asking us to do it order of amortized 1 of 1 time complexity. So what exactly is amortized? Amortized is like average. Like you can't say each operation will be of 1. Okay, it won't be. But amortized is if you take a long average of n operations, the the time complexity is tending towards of 1. So it's like limits, in maths. So your time complexity is not exactly 1, but if like it's like you can be like I don't know if this is a right scientific notation to write or not, but I'm just writing it for my understanding. So limit of n tends to infinity, time complexity of n should be equals to 1, something like this, of 1. So like 1 or 2 operations might are O of n, it's fine, but in the long run, if you divide it by, if the average time complexity has to be O of 1, you can Google it up what exactly an amortized of 1 time complexity is, or what exactly amortized time complexity is. So we have to do all these operations in amortized of 1 time complexity. How do we do that? No agua. Yeah. So one thing, if you have noticed, is when I put here 1, 2, 3, okay, I push 1, 2, 3 slowly, and then I get 1, 2, 3 here, like this, 1, 2, 3, and then while popping, when I bring them to this stack, okay, so these become 3, 2, 1, because I'm like popping them. So if you see one thing here, the second stack, okay, this stack or the first stack, this stack has the order that we exactly want, which is 3, 1, 2, 3, going out 1, 2, 3. So if I keep popping from this stack, it'll act as a queue, because it is inverted, and stack and queue are like inverted in their order. So we can take this into consideration, and we can do things like whenever things come in, we put them in this stack, okay, and we keep this stack unchanged whenever a push operation is happening. But whenever we are popping things, we have to like pop from this stack, so that it simulates what a queue is like. This is like elements keep coming into this stack, and then we put them in this stack, okay, the order is inverted exactly. So this stack has the pop ordering of a queue. So if we keep doing popping from this element, it will be like popping from a queue, as good as that. But the problem is, whenever this queue becomes empty after popping, we have to bring elements in from this element. So I'll give an example. Okay, so 1 is coming, 2 is coming, 3 is coming. I want to pop off 1. So when I want to pop, okay, I'll bring all the things here. I'll do it once, okay. So 3, 2, 1, I bring them here, so it will be 3, 2, 1. And now if you see here, if you look here, now for the next three operations, I don't have to do anything. I can just pop from here, no matter what the elements C are, no matter what elements come after 4, 5, 6, 7, hydrogen, helium, no matter what elements come here, okay, nothing else will pop unless these things are popped first, because 2 and 3 we have to pop these two first. So this no matter how many pushes you do, this has to be, this shouldn't change, this won't change. The only things that will change are this. So we can keep pop for 2 more times. So that's the thing here. So when I first bring the elements into this stack, even though it might take like 3 steps, but for the next 3 steps we don't have to do anything, we can just pop from here. So this is the good thing. So this is what we mean by amortized time complexity. Like in one operation you're doing 3 steps, and for the next 2 operations you're not doing any steps. So if you average it out, it's like one operation per push for each pop. So amortized time complexity of 1. Do you understand? So we'll try to pop from this stack, and if this stack is not if this stack is empty, then we pop all the elements from this and push them here, so that we'll get the queue ordering. And the time complexity is still of 1, amortized of 1, and you know why. So let's get to the code. Okay, so this is the class myQ, which we have to fill in. We have these functions. The first one is the constructor, and the next 4 functions are the functions that we have to implement. And for the stack in Python, I use dequeue, which is a double-ended queue, and which is what they have recommended too, because an array, its array keeps increasing in size. So whenever we try to increase it past its size, it has to make a clone of it has to create a new array with double the size and copy all the elements. It's a lengthy process, and it is time consuming for the computer. So instead we'll use dequeue, which uses like linked list, something like that. So okay, so if you don't know where dequeues are, you have to import dequeues from collections. From collections, import dequeue. Okay, so I'll have 2 dequeues. The first we'll have, sorry, now as we have taken dequeues, we'll only use them as stacks. Okay, we'll only use stack operations on them, so I'll call it stack from now on. So I'll have 2 stacks. Okay, one stack is called s push stack, and one stack is called s pop stack. Okay, now we have 2 stacks. So whenever push operation comes, we won't touch pop stack. Okay, so we'll just do self dot s push dot append is like pop in Python. Okay, x. Fine. Now whenever pops come, here comes the tricky part. First we'll check if the s pop array is empty. If self, oh my god, if if self dot s pop is not empty. Okay, if self dot s pop, like if it's true, that means it is not empty, then I'll just pop from that. So I'll do s self dot s pop dot pop, and I'll return this. But if it's not, I have to pop all the elements from s push and push them into s pop. So while self dot s push self dot s pop dot append self dot, oh my god, so many selves, s push dot pop. Okay, and I'll do that, and once I'm done with that, I'll just return. Okay, I'm not checking here if s pop is empty or not, because they've given us that all the calls to the pop and peek will be valid. So I'm sure that at least one element will be there at the end to pop. So I'm taking, like, I'm testing LeetCode on this. Please, LeetCode, don't betray me. Okay, now peek is similar, but instead of just popping, we'll just look at the last element. So instead of just pop, I'll remove and I'll just print the last element. I won't pop, I'll just print the last element. Yeah, fine. So the last element in dequeue is like the last element which you are going to pop. Fine. So empty is just, I'm checking if both the elements are not empty, or if both the stacks are empty or not, because if both the stacks are empty, then there are no elements with us. So if self dot s push and self dot s pop. Okay, return. We'll just return this. Yeah, I think that should be it. Let me run, and okay, it's fine. Let me run this. Okay. Oh no, wrong answer. Oh, we have to print if it is empty or not. So it's like if not and not, like both has to be not. I'm sorry. I'm really sorry. Yay. Thanks. Yeah. So yeah, that's it. So today's question is a lot easier than yesterday's and day before yesterday's question. Yeah, so we've finally moved on from prefix. So it's time for you to move on from your ex too. Just kidding. So yeah, that's it. I'll be back with tomorrow's questions. Bye.